So the installed programs translate requests to manage normalize access management rules. This is a big one. Managing your policy and your rules across disparate websites is very important. One of the organizations I worked with started out their access management policies this way because they had unauthorized access by populations to their website. So they decided, I'm going to take them all under the umbrella and I'm going to control identity because it's about the only thing I can control. I can't control the developers. I can't control the network connections very well. The only thing I can control is the front door. So they decided to consolidate the front door. And I'll show you how they did that. Agents use the native platform APIs to talk to the target system. I'll talk about two models. One is a reverse proxy-based model. One is an agent-based model. And it usually requires less code modification to the web application when you're talking about agents. They tend to interact at a level below the web app and at the operating system. So if you're talking about Windows authentication, you're talking about doing challenge response, MS Chat or something like that underneath the covers, and it's interacting with that. It's doing it basically has a trust association interceptor that just looks at the call as it's going through and then mimics it. The reverse proxy is much different. So this one is as an example of an agent. You basically reach out with your web browser through a perimeter. You hit a web application server in a DMZ usually that has an IAM agent on it. You have back-end apps, and you assert yourself to one IAM agent, and the arrow I did not put in is basically these things usually talk to each other. So once you assert yourself to one IAM agent, you can actually talk to the other agents in the environment. You still have a policy server, you still have a directory server. One directs rules, one directs identity, and they are very different technologies. Reverse proxy. One of the benefits of reverse proxy is it tends to make a contiguous web space. So you start out with hr.mycompany.com and payroll.mycompany.com and all these different websites. And eventually what it becomes is mycompany.com/hr/payroll. So it all looks like one website, and that's interesting, but it has challenges when you write applications because you have to remain relative to a root. So one of the first things I always tell developers is, instead of putting in your host name, put in a .. So it just goes back to whatever the root was, because that really, it's one of the most basic things, but it really just causes chaos in this model. It also separates users from direct access to the web server. So this is one of those things where you can actually put your web servers on the inside of the enclave, and you can use the reverse proxy as the point. So it's the thing in the DMZ talking, and sometimes that's beneficial to the web application, sometimes it's not. So this model, basically, you come in, show myextranet.com. It becomes, so if you had HTTPS myhrsystem.com, it becomes myextranet.com/myhrsystem or something to that effect. And you're touching the web application servers, and notice that they're inside the perimeter, not in the DMZ. And you're still using the same policies. This is very easy to invoke single sign-on because you're asserting yourself to one entity, and then you're passing that information via HTTP request back to the back end. You can do a lot of interesting things with this model. You can take out a lot of the authorization. You can federate authorization. You can pass it in headers. You can go and grab information from the directory. And I'll show an example of that in a few minutes. Federation. This is where we get into the interesting high-end models. There are two models. There's a local site first model and then a destination site first model. And the local site first model is known as a cross-realm approach. And they talk about this thing in Federation called an artifact. It's basically a piece of information that gets passed between the systems that is able to be opened and identify the person. And it's a common format that they share. So SAML, when you're talking about security assertion markup language or these Federation technologies, you generally talk about an artifact. So in a cross-realm model, the artifact crosses the domains after it's authenticated. And I'll show you that in a second. The model challenges the user first on the local site, and then it asserts to the destination site. And it usually does this, one of the things that the security folks get, we get up in arms at is it usually uses a cookie to maintain state. And everybody has a love-hate relationship with cookies. But it has to touch the client somehow to span the two environments. It has to have something common, and that commonality in this case is the client. So if I were to look at this model, this is from Oasis. This talks about you're accessing the source site, you get a challenge, you log in, then you get a link to a remote application, you select it, then you get a redirect. So basically you're challenged on the source site, and then it redirects you to the receiving site. You can see up here separate, there's a responder and an artifact receiver service that kind of negotiate behind the scenes, and that can be done by a dedicated network connection, or it can be done by a mutually authenticated SSL. But it's usually a secure channel that these two talk to each other on. And then you get a redirect, basically, to the destination site with a cookie. And you're at the remote application. And you notice on this side of the model at the destination site, there's no access checking. You're basically asserting and you're forcing your access. You're saying, I am authoritative. You take my token. Destination first model. This one's a little confusing to try to take a look at it first. They call it artifact approach, and I've struggled with that just because everything has an artifact. But this one's really about who actually starts the artifact. The model redirects access requests directly to the destination site. So you'll see the model in a second, and the traffic from the site of origin is redirected to the target once authorization is complete. So it's kind of a roundabout way of doing the same thing. So let's go through the model again. You access the remote site. In number 2 there, you are immediately redirected to the destination site to its portal. It goes into its processing, so it does its credential challenges on that side, and then basically you are told, okay, you have the SAML request, the SAML response. It does the same thing on its secure channel, and then you end up right back there at there on 6. It actually transfers the artifact back before it does the transfer. So now you're on the other side saying, I don't trust you to assert everything. I'm gonna automatically pass you off to my destination site, and then it's going to tell me you're okay to get in. It's an interesting trust model because you really are placing all the live. And the reason these models are different, most commonly, I tell folks federation is not technically very difficult to do if you understand web services. The legality and the business process around federation can run you into a lot of steps. So these models really are they're technologically focused, but they're also really focused on who bears the risk. In the first model, I bear the risk. In the second model, my partner bears the risk. So if you're talking about basically proving that someone's being fraudulent or what have you, you're passing all that in the second model to the person who's basically being accessed. So you're as a remote portal, all you're doing is acting as a proxy. I'm going to talk about a couple of examples here before we wrap up. Identity management. I've put 2 examples in here. One is a corporate benefits app that I did a few years ago, and the other one is the government PIV standard, and I think there'll be a lot of folks who find that kind of interesting. The corporate IDM integration, the benefits. There were competing requirements to outsource the application, but retain corporate identity control and monitoring. So they said just what I said in the federation talk. They wanted to outsource this. It was cheaper. It was easier for someone else to bear the infrastructure. Has anybody ever seen a PeopleSoft deployment? They're generally very, very big. I mean, they're in a large corporation. They're very expensive, and you have to have a high level of technical competency maintained to do that. If that's not your primary business, your business job is to do HR, they'll go and they'll outsource that. That's the application service provider model. So when this company was looking at this, they said, yeah, but you know what? We don't trust folks with our identity. We want folks to trust us to manage their benefits. Remember I said it's a touchy subject when you get to benefits and pay and things like that. There's also a considerable return on investment. This is the number that I had when we did the project. $7 it cost to make a single call. Now think of a benefits application where you've got 75,000 people changing their benefits on a yearly basis in November. That call center also goes up by magnitude. So let's say they get 200 calls an hour. At tiered levels, they start charging more because they have to ramp up more. So at 5,000 calls an hour projected, they're going to charge you probably $10 a call. I know it sounds counterintuitive, but that's the way they do it because they have to ramp up their capability to accommodate